So the next one we are going to be doing is well, let me tell you some things that was proved using Frobenius method. You see, if you look at Bessel equation, you see Bessel equation is equation of this form: x squared y prime prime plus xy prime plus x squared minus v squared y equal to 0. So this is what we call Bessel equation. You see, just read your slide for this, because nobody, if you use Frobenius method to solve this, because this is also second order, you'll be getting the solution to the Bessel equation. But all these are not necessary to me. They are not necessary. So let me move you to gamma functions. Those ones, so it's just something elementary they discussed there. Let's look at gamma functions. They don't go deep at all. Gamma functions. Now, what is gamma function? Now, pay attention. Are you there?
Yes.
Gamma function. Look at the function here. Gamma function of variable x. What's the definition? It's just like a Laplace transform, but different. There's difference between them. You have integral from 0 to infinity. You will bring a new variable. Here we are using t of this input that you have here, x minus 1, then exponential of negative of this variable, dt. This gamma function. What's Laplace transform? Integral 0 to infinity, e raised to power minus st, f of t dt. So don't be confused. Yeah, the usefulness of all this thing that way, it could come in your those quiz they normally give for this course. So enjoy it. So what condition does this converge? You see, this converges for what? For s greater than 0, and diverges for x less than or equal to 0. All right. So yeah, so it converges for this, and also what? And also continuous. And also continuous. And also continuous. Okay, so take note of that. Okay, that's for that. Okay, let me move this somewhere. Oh, please make sure you write that. I need space. Okay, that's for gamma function. Now, pay attention to something. There are some I don't want to go too deep because let's focus on what is necessary. But take note of what is identity. If I have gamma function of x plus 1, it is the same thing as me saying x gamma function of x. And if I should say gamma function of n plus 1, it is the same thing as n factorial. It's the same thing as what? N factorial. It's the same thing as what? N factorial. Same thing as what? N factorial. And what's n factorial? You know, normally n factorial, what it means now?
Yes, no.
If someone asks you to prove that 0 factorial is 1, don't just stress yourself. You can prove it for them here. You can prove it for them here. Let me tell you something. Let us quickly do one. I'm coming. Let us quickly do one. Let us just play with this function. I'm coming. I don't want to go too deep. Some of my students in other schools go too deep in this, but I don't think you need it. Oh yeah, check. Let's quickly do something. What's gamma function of 1? What's gamma function of 1? Oh yeah, input it here. What do you have? Integral 0 to infinity. If I put 1 here, what do I have? X equal to 1. 0 plus that's 1. So you are left with what? E raised to power minus t dt. And if I integrate this, you'll be having e raised to power minus t divided by minus 1. The integral from 0 to infinity. Don't forget that e raised to power minus infinity is 0. Okay? So you have minus 1 minus e raised to power 0 over minus 1. So what do you have here? Check it out. What will this one give you? This will give you what?
E
0.
raised
Here give you 0. This will give you 1. Positive. This will give you plus 1. And my answer is 1. So gamma function of 1 is 1. Have you seen that?
yes.
Nice. As I've seen that like that, it means that you will see, if I want to prove that 0 factorial is 1, I'll just say, okay, from here, remember, n is an integer. N is an integer, a positive integer. Now, let us say, okay, let's make n to be 0. If I put n to be 0 here, what do I have? Yeah, if I put n to be 0 here, what do I have? I'll be having gamma function of what? Gamma function of what? 0 plus 1 equal to 0 factorial. And what do I
Yeah.
have? Gamma function of 1 equal to 0 factorial. And what's gamma function of 1?
Gamma function of 1 is 1.
1. So 0 factorial is 1. That's one proof. Those further mass comparison, they will say 0 factorial is 1. They might tell you that this proof is beyond the scope of this class. Now, this is the scope now. It's in gamma function. All together.
Yes, yes.
There are other identities there, but it is not needed. It's not even in the slide. So it is not needed at all. So don't just stress yourself. Just enjoy. Can we move on?
Yes, we can.
So the last thing that we are going to be looking at before we call it a night is we want to be looking at boundary value problem. What do I call it?
Boundary
value problem. Let me put it here. Boundary value problem. The difference between initial value. If you are solving most CHE questions, you'll be hearing boundary conditions. I mean, BC1, BC2. Yes. Yeah, it's exactly what we are doing here. What does boundary condition mean? And what's the difference between initial value and boundary? You see, boundary condition, they can tell you that. Look at this thing now. If I say y of 0 is 0 and y of L is 1, what do you observe here? I'm looking at the value at two different points, 0 and L. Are we together?
Yes.
That's a boundary problem. But if I'm just taking at 0 only, I come here, another 0 only. Let me say this one is 2, this one is 5. You can see I'm picking just a point. This is IVP, initial value. But boundary value will look at the problem in two different points. It could be the end point. Let me say you are solving CD question, or let me say transfer. It could be the end point of a rod, and so on like that. So that's boundary value problem. And the type of boundary value problem we are studying here is what we call Sturm Liouville equation. Sturm Liouville equation. Here you'll be asked to find something like eigenvalue and eigenfunctions. Eigenvalue and eigenfunctions. Now you see, pay attention. Don't be scared. It's simple. This Sturm Liouville equation, yeah. Don't worry. I'll just make it a little shorter and just precise. This Sturm Liouville equation. Exactly. This is Sturm Liouville, and let me say that here now, they can give you some boundary problem, but forget about that. Now, look at this thing now. What I want to teach you here is majorly how to find eigenvalues and eigenfunction. You see, they will now give you equation. They will now put boundary problem there. For example, look at this question. I'll give you an assignment. They will say Look at this thing. They say you have y prime prime plus lambda y. Please, I'm coming. My power bank. Let me take my power bank, please.
All right.
Okay. All right. So look at this question. Equal to 0. They gave you that y of 0 is 0. Look at boundary problem now. Y prime of L is equal to 0. Now, the question is to find the eigenvalue value and eigenfunction. Eigenvalue and eigenfunction. They said here lambda is greater than or equal to 0. L greater than 0. Okay. Now pay attention to something. Remember that here they are telling you that lambda is greater than or equal to 0. Abi now? Abi?
Yes, I'm with you, sir.
So it means that we have two cases here. We could consider where lambda is equal to 0. Let's see something. I know what it will be, but let us just see something. Let us look at something. What I'm solving here is like a general problem. If you can study this, you should be able to solve any problem. So now check case 1. Let's look at case 1. When lambda is equal to 0, let's see what happens when lambda is equal to 0. What do we have? You observe that we have something like this. Y prime prime equal to 0 altogether. And remember our D operator method altogether. Hello, do you remember D operator method?
Yes, this is correct.
Yes.
Yes,
So my D1 equals 0, D2 equal to 0. So they are equal roots. Therefore, my y will be equal to what? C1 plus C2x exponential 0x. Have you now?
Yes.
Let me period it so you can remember. Exponential 0x. And that's what C1 plus C2x. Exactly. So that is my solution. Now check. They gave us some boundary problem. When x is 0, y is 0. Now boundary condition 1. When x is 0, y is 0. Oh yeah, let's put it there. What do we have? Y is 0, C1, x is 0. So from here, it means that my C1 is equal to 0. So it means that my equation has now become y of x equal to C2x. C1 is already equal to 0. Abina?
Yes.
Nice. Next, remember they gave me another boundary problem. Y prime of L equal to 0. I have to get y prime by differentiating this. So I have y prime of x equal to, if I differentiate this, you have C2. So they said, yeah, boundary condition 2. At x equal to L, y equal to 0. There's no x here. So I just have my y. There's no x that I want to substitute L here. S has vanished from this differentiation already. So I just have my y to be 0 equal to C2. My C2 is also equal to 0. So check something out. It means that everything I have here is 0. So this type of solution, check. Everything I have here is just 0. See, this guy is 0, this guy also 0. So everything I have here is 0. So what do we call this thing? So there's what we call a trivial solution. What do I call it?
Trivial solution.
Yeah, exactly. Trivial solution at lambda equal to 0. That is mean that lambda equal to 0 can never be an eigenvalue. So in a nutshell, when lambda is 0, we don't have any eigenvalue here. I already know it to be like that. What do you call trivial solution? What do you call trivial normally? English language. I've heard of trivial before.
Like when you're about to do something.
Trivial means something that is not important. Well, let's leave that matter. There is I don't disturb myself over trivial issues. that is issue that is less important. This type of solution now is less important. So let's look at case 2. Let me use that in black. That's the main solving. Case 2 for lambda greater than 0. Oh yeah, between that lambda is not equal to 0 now. So what do I have? Oh yeah, let's go. Solving begin. Y prime prime. This is where the main solving begin. Lambda y. Now this is how to find eigenvalue. This is what you will do. When they say find eigenvalue, you just start your solving from here. Now check. I want to solve this differential equation. What do I do? Remember d operator. D squared plus lambda equal to 0. Then from here, d squared equal to negative lambda. Then my d, if I square root both sides, I'll have plus or minus I root lambda. Don't forget, square root of minus lambda is what? That's square root of minus 1, square root of lambda. What's square root of minus 1? Plus or minus I. Then I have square root of lambda. Exactly. That's how I go there. What am I right? I wrote y here instead of lambda. This is lambda. Lambda, exactly. Now, what's now our solution to this? What's now our solution to this? So our solution, we are having a complex root. What do we say? Go and revise. So C1 cos what? Square root of, don't worry, I'll remind you, don't worry. Let me just write the solution. C2 sine, it can be, it's possible you can forget. Yeah. Exactly. Don't forget, whenever we have complex roots, a plus or minus ib, what's our solution? It become y equal to, okay, let me say alpha plus or minus I beta. You say e raised to power alpha x. Abi, that's it. Then C1 cos beta x plus C2 sine beta x. Yeah, this is it. Yeah, this is it. Yeah, this is it. Hopefully, no, that's it. So that's what I did. So after doing now, this is my solution now. So look at it. Let me rewrite this thing. I have y of x equal to C1 cos square root of lambda x plus C2 square root of lambda x. Good. Now from here, remember we're giving some boundary problem. Don't forget y of 0 is 0, y prime of L is 0. Don't forget. So what do we have from here? Oh yeah, let us put our 0. 0 equal to, now let me write the boundary condition. At x equal to 0, y equal to 2. Yeah, let's go. 0 equal to, x is 0 here, cos 0 is 1. Everything here is now 0 because x is 0, cos 0 is 1. So I'll be left to C1 here. Yes, sine 0 is 0. So you are done already. So therefore, my C1 is 0. So therefore, my equation will now become y of x. Now, C1 is now 0. What do I now have left? I'm now having what? C2 sine square root of lambda x. Are you following?
Yes, I'm with you, sir.
Nice. I have that. And remember my boundary condition too. Because there is a prime here, I'll go and find the derivative of this. Y prime of x equal to, derivative of this is what? Remember, I'll first differentiate this. You have C2 lambda, C2 square root of lambda, and derivative of sine anything is cos of that thing. Cos of square root of lambda x, exactly. All right. Boundary condition 2. At x equal to z, at x equal to L, y equal to 0, y prime equal to 0. So I have 0 equal to, are we together?
Yeah, I'm with you, sir.
Just like this side. Boundary condition 2, at x equal to L, I'm coming, y prime was 0. Same at this side. As x equal to L, y prime was 0. So y prime is 0. S is now L. So I have cos square root of lambda L. Nice. So see what I'm having here. One thing is that my constant C2 can never be 0. Because if it is 0, we have trivial solution again. Since my C1 is 0, C2 must never be 0. So it means that I can divide both sides by also my square root of lambda is not equal to 0 because lambda is greater than 0. Remember our condition, lambda is greater than 0. So let's go. I can divide both sides by C2. So I will now be left with square root of lambda cosine of square root of lambda L equal to 0. Yeah. So from here, I can divide by lambda too now since it's not equal to 0. So it's a number I can divide by it. So I'll be having this. And don't forget, I'm having arc cos of 0. And what's arc cos of 0? Remember that cos 90 is 0. Do you know that?
Yes.
Also, wait, bring your calculator. Do you have calculator with you?
Yes, it's with me currently.
Yeah. Press cos 90.
Cos 90.
Yes, that's like pi over 2 in radian.
0. Cos 90 is 0.
Okay. Press cos that 90 multiply it by 3. What do you have?
In that bracket, I mean.
Like, yes, inside. So you're like pressing cos 270 like that.
That's 0 2.
0. Okay. Press cos 5 times 90.
0.
So what do you observe? It means that what odd multiples of 90 degrees, the cos of that will be 0. So this odd multiple now, I'll be making it 2n minus 1. Because check, make it make sense like this now. When n is 1, when n is 2, what do you have? 3. When n is 3, what do you have? The next. So no matter so just get the I'll be putting this on the side here. So just get the coefficient. So this is the coefficient like this now. So 5 over 2. Exactly. So arc cos of 0, this is like general solution I'm giving you. If I don't put only pi over 2, you did not find general solution like that. But I'm not giving you a broad solving. Let's go. What do we have from here now? We now have to remove this square. Well, everything I'm having, if I divide both sides by L and square both sides to remove this square, I'll be having lambda equal to 2n minus 1 square pi square over 4L square. Exactly. So looking at this side, n is greater than or equal to 1 because of this coefficient. Also, my n, or you can say, sorry, or you can just say n is an integer, either of these two. No, but I prefer n greater than or equal to 1 because 0 is also an integer. So this is what I have. This is my Ig value. This is my Ig value. This is my Ig value. Right. So how do we get Ig function? Oh, simple, go. Remember that my y is equal to C2 cos. Wait, I'm coming. Check my y. Remember, my main y, this is my y now. C1 is 0, so this is my y. Abi now.
Yes.
That's C2 sine square root of lambda x. All right. Okay. Come on, easy. Now let's go. Oh yeah, your Ig function is simple. Your Ig function is simple. This Ig function. So just put your Ig value inside this. That's what you do. Remember, what's square root of lambda? Square root of lambda is just like for you to take away all these squares that you have here. Take all of them away. That's square root of lambda. So my y will be equal to C2 sine. What's my square root of lambda? 2n minus 1 pi all over 2l. Then I'm having my x for n greater than or equal to 1. That is my Ig function. Yeah, this is the end of everything. So for this one, let me give you an assignment. This will be your assignment. And this is the last thing we are doing. This is the last part of the first part of the course. So this is the assignment. So they said that find the eigenvalue and the eigenfunctions of y prime prime minus 4 lambda y prime plus 4 lambda square y equal to 0. Y of 0 is 0. And y of 1 plus y prime of 1 is equal to 0. So just solve by getting your, just solve, see, solve from something like this. Like solve from how I started this one, this case 2 here. Just solve like just continue solving from here. You don't need to show any case that something is a trivial solution. So, any question?
No, not at all. Thank you so much.
So try to go and practice this ones very well. And we're doing the second part, that's Professor Osholeke's part. So once in a while, you can just be coming with some past question that is on this first part. Then we can solve it on this live here. You understand?
All right, sir.
That's that for that. So take care.
Thank you so much. Bye bye. Good night.